Welcome to this tutorial to help you finish the pivot lab about the coefficient of friction between the man's boots and the ice. At this point you should have the motion graphs that are pictured here. Hopefully you have trends like I have, a flattening curve on the position time graph and a falling line on the velocity time graph. And you're at the point of the lab where you are asked to use Newton's second law and the acceleration that you found to find the coefficient of friction. So remember that we can never use Newton's second law effectively without a free body diagram. So I'm going to draw a free body diagram for the man on the ice now. So there's the weight downward. There's the ice supporting him upward. And then most interestingly, right, if you think about the horizontal forces, there's only one force in the horizontal direction, and that is the force of friction that is slowing him down. One more thing of note, we have effectively used a coordinate system that is like this, right? To the left is positive and up is positive. Okay, so that's going to help assign the correct values of the forces, right? Positive or negative. Let's go to the next screen and write F equals ma in the x and y direction based on a free body. On the y side, we have the normal force minus the weight equals 0, right? There's no acceleration in the y direction, so the forces are balanced, which you already knew, right? You knew that just by looking at it. But it's nice to be able to write what you know in your brain mathematically. I've also substituted in weight, right? Weight is mg. Now I can come to the x side, okay? In the x side, we only have the one friction force. Notice, however, that it's negative, right? Because the force is to the right, which is the negative direction for our particular problem. Now we get to substitute in our new formula that you just learned, right? The formula for friction. Mu times the normal force, and in this case, is it static or kinetic friction? That's right, it's kinetic friction, okay? Equals ma. Remember, we're trying to solve for mu, and this, when we look at this equation, it presents a bit of a problem because we don't have the mass of the person. Right? But now you get to experience something wonderful that physicists like to do all the time, is they like to work in symbols and reduce it down to as few symbols as possible before they plug the numbers in. So what we're going to do is we are going to take this value here from the y side and we're going to plug it in right there. And that's going to give us this. And now you see a wonderful thing happen. Okay? You see the masses cancel. And that leaves you with a very simple formula. Mu k times 9.8 equals the acceleration. So now you would plug in the acceleration that you found from your velocity time graph. You'd plug this value in and you could solve for the coefficient due to friction. The coefficient of kinetic friction, right? Finally, I'd like you to include this work in the lab, right? There is a text box for doing so. You can either type this up, which is a little bit awkward, or you can write it out by hand, take a picture, and upload the picture. Good luck.